The nozzle assembly is very similar to what we've had in previous generation injectors. We got hydraulic force that acts upon the bottom of the nozzle needle, causing it to lift up during the injection process and spray out of the small orifices in the end of the tip. They are spring-loaded in the closed position, so it does require hydraulic force on the bottom of the nozzle needle to cause it to hydraulically lift up. So we go a little bit further into our injector. We have our connecting plunger, or what we refer to as our hydraulic coupling device or hydraulic amplifier. And this is the device that's going to transfer the piezo stacks movement all the way down to my switchover valve. Another way to think of this thing is it's like a hydraulic valve adjuster in your normal valve train. It takes up any clearances, any dimensional changes that we have inside the injector body. So as the injector expands and contracts with thermodynamics, this hydraulic coupler acts as a slight lash adjuster, always keeping tension between my piezo crystal and my valve group that's sitting below this. This also functions as an amplifier circuit. So I've got a large piston on top and a smaller piston on the bottom. So the piezo travel will get amplified down to move over the switchover valve. Alright, one thing to keep in mind is this coupler has to stay free of air. As we all know, air is extremely compressible. So if I aerate this connecting coupler, or if I have air pockets caught in this connecting coupler, guess what happens? The injector fails to function. The piezo crystal will expand up on top, trying to switch over the switchover valve, but since it's compressing an air pocket, the valve never actually opens and the injector does not function properly. So how can I aerate this fuel? Well, there could be a couple different causes. For one, if I don't have proper return line pressure. Remember, we have a pressure retention device that's supposed to hold 150 psi of pressure. If I don't have that pressure behind there, I can actually aerate this coupler. As this coupler is moving back and forth into its stroke, if I don't have sufficient pressure behind it, I can actually aerate the diesel fuel inside of there. And you may have a drivability concern as the car might start fine, might idle okay. But once I really go under heavy acceleration, where I'm requiring that crystal to expand and contract at a very rapid rate, I'll aerate that fuel inside of that coupler and the vehicle will start to stumble or the vehicle will start to shut off. Okay, so if we move on through, we have our switchover valve. So our switchover valve is directly activated by the hydraulic coupler sitting above there. So this switchover valve is the device that's sealing the high pressure area to the low pressure area. So low pressure area is that side that's on the return connector. So the low pressure is going to be that 10 bar, 150 psi of pressure. The high side pressure is going to be several thousand, up to maybe 30,000 psi of pressure. Extremely, extremely high pressure. So how does this all work? Well, we got a few different parts inside of here. As you can see, we got them labeled. We've got our throttling plate. Our throttling plate is going to consist of several different orifices. You can see our high pressure bore, which will go down and fill up our high pressure zone. We got our valve seat area, the valve spring, the valve plunger. And inside of this throttling plate, we got a couple different bores. We have an outlet throttle, we have an inlet throttle, we got our high pressure inlet that goes down to the bottom of the injector, as well as the bypass valve inside of our throttling plate. And all these pieces will come into play in a few minutes when we see how this exactly functions properly. So let's look at this condition. We got the injector waiting to fire at this point in time. Everything in this red zone is considered high pressure fuel. Anywhere up to 1800 bar, 26,000 psi of pressure. The low side is going to be retained right at 10 bar, 150 psi of pressure. So at this point, I've got hydraulic force in this control space plus valve spring tension causing the needle to stay closed. Now I want the needle to open. What actually has to happen? Well, my piezo crystal expands. I transfer that force to the connecting coupler down to our switchover valve. Our switchover valve opens, creates a small leakage, causing a reduction in pressure. The reduction in pressure relieves the hydraulic force we have up in this control area. Now this control area has less hydraulic force in it than the bottom of the needle. And by simple hydraulics, it's going to force the needle to open. The needle is going to open and I'm going to start spraying fuel into the combustion chamber. So now I'm done with that injection. I've done one single injection. I need to end that injection process. So the EDC controller will reverse current to the piezo crystal, cause that crystal to compress close against one another. The hydraulic coupler will move upwards and travel, cause a switchover valve to move up and close the sealing surface. I'm going to take my hydraulic pressure that I have here and now refill this control space. But we want that needle to close extremely quick. We want the injection to end as fast as we possibly can. So I will fill through the inlet of the throttle bore as well as filling through the bypass and the outlet of the throttle bore in order to properly refill this control space to hydraulically drive the needle back down, causing my injection to end.